Hello student, let's try to understand integrated zero order reaction. So suppose student, it is the zero order reaction, it is happening R reactant to product. So if you are writing a student, rate is proportional to what is the concentration of what is student reactant raised to power 0, because it is zero order reaction, so power will be 0. If you are writing rate is equal to student, so proportionality constant you can remove, so what will be there student, r power going to be 0, k r power 0. K is integration constant student. Okay, this is also I am writing here student rate constant for zero order reaction. Rate K means rate constant for zero order reaction. Zero order reaction. This is right student. Now what we have to do, integrated equation we need to know student. So we are going to integrate this equation student. Okay. So we can on integration. So how can we try to integrate student? There is rate we can write here is dr by dt. Dr by dt is equal to k r power 0. This equation can be integrate this equation. Which equation? This one equation 1. Here I am writing. So how can you integrate student? So integration can be done of the similar term with student. We cannot do the integration of the different terms, because here the numerator is r, denominator is t. So we cannot do. And you know student, r power 0, anything value power 0 means 1. A power 0 it is going to 1. 100 power 0 means it is going to be 1. So we will firstly how we are going to write this equation. See, minus dr equal to dt, I am changing this side student, k dt this will be, or you can write dr is equal to minus k dt. Now if you are integrating this one student, this one is dr is equal to constant cannot be integrated student dt. So on integration it will give student r, because integration of dr is what student, that is r, and integration of dt equal to t. So r is equal to, it is minus kt plus I. This I is what student, integration constant. This is nothing but integration constant. Right, this is there student. Now what we can do here student, this is equation we are considered to be 2. At time t is equal to 0, if time t equal to 0 student, so r is equal to, it is going to be what student, initial concentration or not. So from equation we can go 2 student. So r at the place of r we can write r naught student, minus k at the place of t it is 0 plus I. So I is equal to, it is going to be what student, r naught. Now this is 3. From 2 and 3 you can go from 2 and 3. If you are writing from 2 and 3 student, what can you get here? So from 2 I value we are putting in that one student, r is equal to minus kt plus I means r naught student, r naught. Kt can come here this side student, so kt is equal to r naught minus r, r naught minus r student. So k is equal to, it is going to be what, r naught minus r upon, it is what student, time. This is the integrated equation for the zero order reaction student. Now we are going to solve the half life period of the zero order reaction, student. अब you should try to know, student, in case of half life what happen. Half life means, student, the concentration become half, student. Okay, concentration become half, right? So half life, we are going to derive half life period. Half life period. So half life period, how can we write, student? So T is equal to, we are putting T1 by 2, student. So R is equal to, what we can put, student? R naught by 2, right, student? This is what the equation. So from this equation, equation 4, from 4, what we can write, student? K is equal to R naught, right? So R naught, student, it will be same as it is. So we are writing R naught. R is equal to R naught by 2. So here we are writing R naught by what, student? 2. And total time is how much is there, student? T1 by 2 we can write. Now we can derive little bit, solve more, student. T1 by 2 is equal to R naught. Here is the R naught by 2 divided by K. If you are solving, student, T1 by 2 is equal to 2 R naught minus R naught here upon 2K. So what will come, student? R naught, it will give, dear student, it will give R naught upon 2K. So T1 by 2 is equal to R naught upon 2K. So this is half life period of the zero order reaction, student. Now what we can do, student, we need to graph of the zero order reaction. We need to know the graph also, student. Graph of zero order reaction. Zero order reaction. So here is K is equal to, what is, student? We know what we are having, R naught minus R upon T. So Kt is equal to, we can write also R naught minus R. So here if you are comparing this equation, student, but it is very difficult to compare, student, view, because y is equal to what, student? Mx plus c na. So single term should be coming this side. So R is equal to, it is going to be R naught as it is minus Kt, or na, R is equal to minus Kt plus R naught. So you can compare y is equal to mx plus c. So what is there, student? If you are comparing, what you are going to get this? You can draw the graph. Suppose this is x, here is y. So x axis, what is there, student? X axis. Here is at x axis you are taking the time. This is time. On y axis, student, you are taking the concentration, R. So intercept is there, student, here. What intercept is there, student? This is the R naught. Intercept R naught. And here is slope is where, student? Slope is negative slope. So it will come minus m, minus k. So slope is equal to how much, student? Minus k. So intercept is more, student. This is the intercept, you can find this one. R naught. Intercept is R naught. This one. This is C is what? Intercept. Okay. So this way you can derive, student. Not too difficult. Thank you.